What is biasing of PN junction diode? All of you listen carefully. Now biasing means what basically? Now the application of external voltage to a PN junction diode, that is called biasing. What do you call? Application of external voltage. Right? Biasing of a PN junction. What is that? Biasing of PN junction. Application is what basically? Application of external voltage. Biasing of PN junction. What is that? Now the application of external voltage to the PN junction diode. PN junction diode is called, the application of external voltage to the PN junction diode is called biasing. Called basically biasing of PN junction bias. So there are three types of biasing. First, no bias condition means that is no voltage applied. Another next two types of biasing will come, basically forward biasing and reverse biasing. So first to write number one condition. I'll write here types of biasing. Number one, write no bias condition. No bias condition. What do you mean by no bias condition? All of you listen. A PN junction is there, a P is there, N is there. Now here you have not applied any potential here. No potential you have applied. So potential application 0 here. Or in symbolically you can give like this symbol. No potential is applied. So P and N, no potential is applied. This is called here no bias condition. In no bias condition, what happens? Here no current flows. No current flows through the diode. No current flows through the diode. Okay, at equilibrium. Now next, one thing remember here, in no bias condition, your N side is at higher potential. N side is at higher potential, remember. And okay, or with respect to P side, higher potential relative to P side. Sorry, N side is higher potential relative to P side. Remember that. No bias condition, your N side is at higher potential, because in N side you have what you have, say N side you have positive acceptor impurity. So N side will be little higher potential. This question comes in at equilibrium or at no bias condition. N side is at lower potential or higher potential than P side. N side is higher potential than P side. Yes or no? That idea remember. No bias condition. Here no current flows. Clear idea? The next condition is basically what? Reverse bias and forward bias. Okay. So first listen. Forward bias. First listen. Forward bias. Forward bias. What is forward bias? What is forward bias? Now when P side of PN junction is connected to higher potential and N side is connected to what? Connected to lower potential. Connected to lower potential. then PN junction is said to be forward biased. Then PN junction is said to be forward biased. Complete. Said to be forward biased. Write down. So give here how forward bias condition. Now like this. Your P side, your N side. Now here connected high potential, here connected low potential. See one battery connection. Positive terminal battery high potential, negative terminal of the battery low potential. So now P side connected to high, N side connected to low. This also can be written as how? Like this also you can write. All of you listen carefully. Positive connected. Okay. And this equivalent circuit, what you can write? Equivalent circuit is this diode is working. Diode is working. So current is flowing here. Current is flowing here. Okay. Diode is working. Current is flowing. So this is the external voltage. External voltage. Okay. V is external voltage given. So just it will act like a normal circuit. Normal. So on condition. It is on condition. It is closed circuit condition you can write. Closed circuit. CKT means circuit I am writing. Closed circuit. Okay. If forward bias na closed circuit. Reverse bias is open circuit. They are not on. So it is closed circuit like work. Closed circuit. So some current will be flowing here. This current is due to majority charge carrier. Current is due to majority charge carrier. So here some current will flow. So here write current through diode is due to what? Is due to majority charge carrier. Majority charge carriers. Majority charge carriers. Current is due to majority charge carriers. Write down about forward bias. Let me complete it, after that you write. Forward bias. Understood what is forward bias? In forward bias, diode will work or not work? Diode will work. And here see, here one, if it is ideal diode, this diode is ideal diode, across this potential is 0. Otherwise 0.7 or 0.3 potential will come. Okay. Remember, diode is if ideal diode, no potential drop across this in this point. Not potential drop across diode. If diode is a real diode, then 0.7 volt for silicon and 0.3 volt for what? Germanium. That one you would write. Okay, listen. First you understood what about forward bias. Then forward bias, what happens? All of you silent please. Listen carefully. In forward bias, some other points you remember. What are the other points? Now the width of the depletion region or depletion layer. Remember, in forward bias, this question comes. In forward bias, what happens to depletion region? So in forward bias, the width of depletion region decreases. Remember, decreases. Okay, how it was for no bias condition, as compared to that, width will decrease. So remember, in forward bias, what happens? The width of the depletion region decreases. And here, one barrier potential versus distance graph will do. Variation of barrier potential in forward bias. So right here, one point will remember, variation of barrier potential in forward bias. Listen all of you. In forward bias, what is the variation? Now if I'll take here potentials like this, I'll take potentials like this. Here 3 potentials let me take. 3 potentials let me take like this. Okay. Number 3 Number 3 is basically what? Forward bias. This is number 2, forward bias with low voltage. This is the number 1 is no bias condition. See here. Here this is your VB. Now what is happening here? Listen all of you. If I am increasing potential, external potential, this VB value will decrease from 1 to 3. So I'll write what is 1, 2, 3. In exam it is coming question. You remember this diagram properly. Let me write what is 1. Okay, what is 1? Now listen all of you. This 1 is barrier potential. Barrier potential with no bias. All of you listen, with what? With no bias. No bias condition. Number 2. No biasing condition. Number 2 is what? Barrier potential with low battery voltage. See, same barrier potential with low battery voltage. Low battery voltage. And listen, number 3. Number 3, same barrier potential with high battery voltage. So in exam it will be asking here. This 1, 2, 3 in forward bias, suppose you tell what all this represents. 1 represents barrier potential with no bias. All of you listen. When you listen low battery voltage applied, barrier potential decreasing, then more decreasing. In 3, more decreasing when high voltage is applied. Okay, this is ditto written, ditto. That means barrier potential. You can write once. This is your barrier potential. Barrier potential. This is also barrier potential. Barrier potential. So this is all about your forward bias. In forward bias, diode is in working condition. Listen, I'll come to before page. Just let me complete. Let me complete. See, forward bias, in forward bias, diode will be in working condition. So current is coming due to majority charge carrier. And if you variation of barrier potential and forward bias, you are checking it is coming like this. And if you want to understand what is width is happening, then forward bias, the width of depletion then decreases. Okay, this idea you remember please. This is a direct question. How width depends on forward bias and reverse bias. In forward bias it decreases, reverse bias increases. So now next point is reverse bias. Okay, the reverse bias, what happens? Check. The reverse bias, all of you listen. When P side is connected to low potential, and N side is connected to high potential, then diode is said to be what? Said to be reverse bias. Said to be reverse biased. In this what happens, how it is? Now see here, suppose I am taking it is a PN junction. This is P, this is N. Yes or no? Now P side connected to negative potential, N side connected to positive potential. Negative means low potential, positive means high potential. Now in this condition what happens, you see all of you. So in symbolically also you can tell. See, Darshan, you tell which is the P side here, which is the P side? Triangle. Triangle is P side. This was straight line is N side. So a P connected to low, N connected to high. Okay. So in this condition what happens? Diode will not work. Then it will behave like which circuit? It will behave like a open circuit. It will behave like what? Open circuit. No current flows here. Okay. No current flows due to majority charge carrier. Due to minority, some small current will be there. That is negligible. So no current flows. It is open circuit will happen. Yes or no? So when diode is reverse bias, no current flows. Yes or no? This much things you remember. A little other point you can write about depletion region. Tell me what happens in depletion region here. Karma, remember. The depletion region. The depletion region increases in reverse bias. Increases in reverse bias. Depletion region will increase. Okay, basically the width of the depletion region. Right here, star mark point, right? The width of depletion region increases. Okay. Now next barrier potential variation little will check. Okay, barrier potential variation. Any current flows here in reverse bias? Any current is there? Current is there, but due to minority, which is very less, negligible you can tell. But majority current is zero. So overall current you can tell zero. That is not working for ideal diode. Now one point listen here. Variation of barrier potential. So variation of barrier potential. How barrier potential varies? Check in reverse bias. In reverse bias, how barrier potential changes? We check here. Now suppose I will consider like this. Two graphs I consider like this. See here. Now one graph, this is 1, this is number 2. So 1 I'll give as BB. Now all of you listen here carefully. Here 1 represents what basically? No bias condition, no bias. 2 represents reverse bias. 2 represent reverse bias. When reverse bias happens, your barrier potential increases. Suppose you have applied V potential here. You have applied V potential here. Now here what is happening? Here barrier potential will become VB plus V in reverse bias. Okay. But in forward bias it will be VB minus V. Like that it is happening. So this idea you remember about forward bias and reverse bias, or all together biasing of PN junction. Clear idea? Okay. Thank you.